Good afternoon, my YouTube viewers. It is Crystal here, and in this particular video, what we're going to be talking about is time series analysis and time series forecasting in R. This is the second time that I have made this video because the first time I had some difficulties with my screen recorder, and then when I tried to run the program, it wouldn't run, so I'm running it a second time. So time series analysis is a specialized branch of statistics used to analyze data sets where observations are recorded over time. Its central aim is to understand the underlying patterns, trends, and dependencies within the data and to make predictions about future values. Unlike other forms of data analysis, time series analysis focuses on the temporal ordering of data points, which is crucial to understanding how values evolve over time. And so, a lot of people may not realize that time series analysis and forecasting is a part of statistics, but it is a part of statistics. And so, you've got your key components of time series analysis include trend, which is the long-term movement in the data reflecting overall increases, decreases, or stability over time. You've got seasonality, which is regular repeating patterns or cycles in the data, often tied to specific times such as month, days, or quarters. You've got cyclic patterns, which are fluctuations that occur over longer, irregular periods, often influenced by economic or environmental factors. And you've got noise, which is random variations or residuals that cannot be explained by the trend, seasonality, or cycle. So in order to show you how to do time series analysis, what we're going to do is we're going to simulate some data. We're going to simulate daily temperature data over a 1-year period. And so simulating applying temperatures is a very common thing that you can do time series analysis on. So the first thing we're going to do is we're going to set our seed. And the reason why you set your seed is so every time you run the program, the variables are going to be initialized to the same value. So you type set.seed brackets 1, and then you can put any number that you want within the brackets. So the number of days in the year is going to be 1 to 365. We're going to create a seasonal temperature pattern using a sine wave. So peak in the midsummer around 200 and low in the winter. So temp becomes 10 plus, that's your baseline temperature, 10 times sine brackets 2 times pi times days divided by 365 minus pi divided by 2 plus R norm, that's a randomly sampled normal distribution of 365 samples and a standard deviation of 3, and that's your random daily variation. So we're going to plot the daily temperatures. So plot brackets days, comma, temp, comma, type equals L, letting you know it's a line, color equals a steel blue, line width equals 2. XLab is your label on your x-axis, which is the day of the year. YLab is the label on the y-axis, which is temperature in degrees Celsius. Main is the title, is simulated daily temperature over 1 year. We're going to add a smooth line to show the seasonal trend. So lines, brackets, lowest. Lowest is a function that you can use to smooth the data. Brackets, days, comma, temp, comma, F equals 0.1. Color equals red. Line width equals 2. and then we're going to add a legend. The legend is going to be on the top left. The legend is going to be a vector that says daily temperature and seasonal trend. The color is going to be a vector with daily temperature being blue and seasonal trend being red, and the line width equals 2. So we're going to run the program, and when we run the program, we have our plot. We have a half of a sine wave being from day 1 to day 365. And so you can see that the highest temperature is going to be around day 200, which is going to be in the summer, and the low temperatures are going to be around day 0 and day 365. So blue is your daily temperature, and you can see that your daily temperature varies from a low point to a high point. But your seasonal trend, which is calculated using the lowest function, smooths out the temperatures so you can get a smoothing. So it's a little bit easier to tell what the smooth temperature is going to be. And so the great thing about R is a statistical program written for statisticians. So it's got these time series functions inbuilt in the program. And Python, which is the programming language that I started out with, that is a general purpose program. So if you want to have any time series analysis or time series predictions, then what you need to do is you need to import libraries to do that. And so you've got scientific library of SciPy or statistical library of stats models, and then you also have visualization libraries of Matplotlib and Seaborn and ggplot. And you also have like data manipulation libraries of pandas and numerical libraries of NumPy. And then what you would need to do, because Python is a general purpose library, you would have to import these different libraries that you would need to perform time series analysis or time series forecasting. But the great thing about R is you don't need to do that. All of these functions are inbuilt into R. So next thing we're going to do is we're going to simulate stock prices with trend, seasonality, and noise. And a lot of people like that on the programs that I've written, programs that I've written about, the programs that I've reviewed and made videos on, and articles in Medium. The thing that the people are the most interested in is the stock market, because people want to know how they can make money on the stock market. So they want to know how they can, one, plot the data, but more importantly, make a forecast of what they think is going to happen to the prices in the future. But what I would say, the only thing that I can do is I can tell you how to plot it, and I can tell you which forecasting models to use. But I certainly can't give anybody any advice, because when you put money in stocks, it's a very volatile business to get involved in, and you can lose money just as easily as you can make money. So you shouldn't put any money into the stock market that you really need. You should only put money into the stock market that you can do without, because you can lose everything just as easily as you can make a fortune. So in order to simulate the stock prices with trend, seasonality, and noise, the first thing we want to do is we want to set our seed. And the reason why we set our seed is so every time you run the program, the variables are going to be initialized to the same value. So we type set.seed brackets 1, and you can type any number you want within the brackets. So now what we're going to do is we're going to define our time index, which is 1 year of daily trading, which is approximately 252 days. So you think that they're only going to trade Monday to Friday, especially in the US and the UK. And so 5 times 52 is 260 days. And then in America in particular, you have 8 holidays, or in the UK, you have 8 holidays. I'm not sure exactly how many holidays, but they say you've got 8 holidays. So 260 minus 8 is 252. So you're going to say that you're going to have 252 trading days in a year. So our days becomes 1 to 252. Now we're going to set up the trend component, which is a slow upward drift. So trend becomes 0.05 times days. And now we're going to check the seasonality, which is weekly cycles of 5-day trading week. So seasonality becomes 2 times sine, brackets, 2 times pi times days, divided by 5, because you've got a 5-day trading week. And then we're going to set up our noise, which is your daily volatility. So noise becomes R norm. That's a randomly sampled normal distribution, brackets, 252 samples with a mean of 0 and a standard deviation of 3. And then we're going to combine the components into a stock price series. So price becomes 100 plus trend plus seasonality plus noise. So 100 is going to be your base price. And then you add this trend, seasonality, and noise. And then we're going to plot the simulated stock prices. So the plot, brackets, days, comma, price, comma, type equals L, letting you know that it's a line. Line width equals 2. Color equals steel blue. X lab is your label on your x-axis, which is the trading day. Y lab, which is your label on your y-axis, which is your stock price. Your main is your title, which is the simulated stock prices with trend, seasonality, and noise. We're going to add a smooth trend line, so we're going to smooth out these values. So lines, brackets, lowest is the smoothing function, brackets, days, comma, price, comma, F equals 0.1, color equals red, line width equals 2, and then we're going to add a legend on the top left. So you have legend, brackets, top left. Legend is a vector that contains simulated price and smooth trend. Color is also a vector. So simulated price is steel blue and smooth trend is red and line width is 2. So we run the program, and when we run the program, we have a simulated stock prices with trend, seasonality, and noise. So your simulated price is in the blue, and then that's going to be randomly sampled every day, and it's also going to have noise in it. And your smooth trend is the lowest function, and so you can see the smooth trend gives you a general idea that the stock prices are slowly moving upward. And then this is a trading day from 0 to 252, which is a year's trading. And then you have a stock prices with 100 being your starting point and about, 115 being the smooth stopping point. So now what we're going to do is we're going to give you another demonstration of a program that is an example of forecasting. So we're going to have time series forecasting example in base R. So what we're going to do is we're going to make predictions on future data. So the first thing that you want to do is you want to set your seed. So every time you run the program, the variables are going to be initialized to the same value. So you type set.seed brackets 1. and you can put any number you want within the brackets. So we're going to simulate a time series with trend and noise. So days is 1 to 200, and your trend is 0.1 times days, and your noise is a randomly sampled normal distribution, or norm, brackets, 200 samples, and a standard deviation of 2. Y is your dependent variable, is 50 plus trend plus noise. And then we're going to convert it to a time series object. So TSY becomes TS, which is for time series, brackets Y, comma, frequency equals 1. And then we're going to fit a simple ARIMA model with an auto-selected order. So you fit the ARIMA, fit becomes ARIMA, and ARIMA is actually 3 models in one. The AR is the autoregressive, the I is the differencing, and the MA is the moving average. So you've actually got 3 functions in one. And then the ARIMA model takes TSY, and the order is a vector of 111. Now your 111 stands for PDQ. So, and then if you go through and look at my playlist, I do actually have videos that I've made where you can calculate the order using the PDQ using a for loop. And this order with the PDQ is going to be like 0 to 8 or 1 to 8 because R doesn't really use a 0. Our number starts with 1, so it might be 1 to 8 or 0 to 8 or 1 to 3 and 0 to 3. And then what you do is you plug this for loop in, and then what that does is that helps you to calculate the best order. So the order that we've got in here isn't really very good, but it's just there. But what you have to do is you have to set up the order, and then when you set up the order, then it will give you the lowest noise. And then because the thing is it calculates the lowest RMSE, which is root mean squared error, and you want your RMSE to be as low as possible. The higher the RMSE is, the greater the noise and the greater the error. So we're going to forecast this in the next 30 days. So pred, that's your prediction, becomes predict brackets fit, comma, in dot head 30. So that means it's predicting it for the next 30 days. And then so we're going to plot the historical data. So plot brackets TSY, comma, type equals L, color equals still blue, line width equals 2. X lab equals is your label on your x-axis is time, and Y lab is the label on your y-axis, which is value, and main is the title, which is time series forecast times R. So we're going to add a forecast line, and lines brackets 201 to 230. So that's going to be after the 1 to 200. And that's going to be pred, $pred, color equals red, line width equals 2. And then we're going to add the forecast confidence intervals. So lines, brackets, 201 to 230, pred, $pred, plus 2 times pred, $SE, that's standard error, color equals orange, LTY equals 2. And then you put a second line in there, lines, brackets, 201 to 230, pred, $pred, minus 2 times pred, $XE, color equals orange, LTY equals 2. So the LTI lets you know that it's a dashed line. Then we're going to put a legend in here, which is legend, brackets, top left. Legend is going to be a vector that we've created that says historical data forecast 95% interval, and that's your confidence interval. Color is going to be another vector that we have created. So the historical data is going to be still blue, the forecast is red, and the 95% interval is orange. The line width is 2, and LTY is another vector that we've created. So historical data and forecast are going to be a straight line, and the 95% interval is going to be a dashed line. So let's just run the program. And when we have run the program, you can see we have a time series forecast based R. So your historical data is in blue, your forecast is in red, and your 95% confidence interval, you can see it right here. It's an orange dash. So you've got 95% on the lower end and 95% on the upper end. So that's telling you that it can fall anywhere from the lower end to the upper end. But what we're going to do is we're going to change the order. I'm not sure if it's going to work with 0, but we'll just say 0, 1, 3, 2, 0, 1, 2. See what happens. I'm just trying to get it to run. So it ran and it worked. So you can see that when you change the order, that it very slightly changes the prediction. So let's try this. 3. I'm just trying to change the numbers just to see if it will change the prediction. But what you're looking for is, and you can see it's done a little bit, and that's what I wanted to show you. This is not necessarily the optimum order that you can use, but what I wanted to do is I just wanted to put an order in there where it's not going to be a straight line, because a straight line isn't telling you much. But if you go back and look through my playlist, I've got some playlists for R programming. And if you look through my playlist for R programming, I'm sure that I've got some videos on the ARIMA model and the SARIMA model, and I go through how to put this for loop in here to set up the PDQ for the ARIMA, and then for the SARIMA, it's something else, it's 4 digits. But that's what I wanted to do. I just wanted to change the order so you can see that when you change the order, it actually changes the prediction. But what you want to do is you want to set the order up. You want to set the for loop up so it will give you the order that gives you the lowest RMSE. That's your error. So that concludes this video. I hope that this video works, because the first video I made didn't work. I hope that you got something out of it, and I'll be making another another statistical video in R for you very soon.